Welcome to the DX Today podcast where you get fact without all the A-hype. And that is so critical right now because for the last, 2 years, we've all just been swimming in the hype cycle of generative AI.
Oh, absolutely. Chatbots, text
Yeah.
generation, image creation, it's been everywhere.
It's been everywhere. But the sources you've shared with us, they really cut through that noise. They suggest the industry is it's already pivoting to the next thing.
And it's a much more strategic and, frankly, a much more disruptive phase.
Agentic AI.
Exactly.
So our mission today is to do a real strategic deep dive into this transition. We're moving from tools that are, fantastic at talking to systems that are built to execute. And this just completely rewrites the value proposition for professionals, how organizations are structured. I mean, what a job description is even going to look like next year.
Right.
We're going to map out the facts. We're going to look at these emerging job roles, the builders, the orchestrators, and really show you how to position yourself like right now.
And the context is just so crucial for understanding the urgency here. The analyses we're dissecting, they're focused so intensely on agentic AI career preparedness strategies.
Right.
We're not just watching a software iteration. The sources call it an ontological shift in machine intelligence.
An ontological shift. Wow.
Yeah, it's the ability for an AI to actually hold a long-term goal and actively pursue it. This is the groundwork, the technical foundation for what big organizations are already calling the autonomous enterprise.
Or the frontier firm. I saw that term a few times.
Or the frontier firm, exactly.
Okay, so to really get our heads around why this is happening so fast, we have to start with what your sources are calling the GenAI paradox. It's this massive disconnect, right? Enterprises are reporting really high adoption. We're talking nearly 80% using tools like ChatGPT, Claude, internal LLMs.
The adoption is huge.
But at the same time, they're reporting, almost no measurable bottom line impact. They're spending the money, they're spending the time, but efficiency isn't skyrocketing. Profits aren't jumping up.
And that paradox, it exists for a very specific reason. It's because GenAI, as brilliant as it is fundamentally stateless and reactive.
Okay, what do we mean by stateless?
I think of it like a brilliant consultant,
Yeah.
but on a very, very short-term contract. It answers a prompt beautifully, but it has zero memory of the last conversation.
Right.
It can't track its own progress towards a goal, and it can't independently take any action in the real world. You, the human, have to constantly prompt it, check its work, edit, and then execute the next step yourself.
So you're the pilot, constantly at the controls.
You're always the pilot. And that's where Agentic AI comes in. It's the explicit solution to this paradox. It's designed to turn all that raw information and text generation into quantifiable, autonomous, outcomes.
All right, let's unpack this. So let's start with that defining difference. The sources use this really powerful analogy to separate the two, and I think it's perfect. Generative AI is like a brilliant brain in a jar.
I like that.
It has this immense cognitive ability, right? It can reason, it can synthesize, produce perfect language, but it has no hands, no long-term memory, and no way to interact with the world outside of the single prompt you just gave it.
That's the perfect description of the chatbot era. The large language models we've been using are purely reactive. They're waiting for input, and their whole operational memory is just confined to that one conversation's context window.
And once you clear the chat,
It's gone.
uh,
The system forgets everything, the goal, the constraints, the previous steps. So if you have a 5-step task, you have to feed it all 5 steps of context and instructions over and over again.
you're repiloting it at every single stage. That's the statelessness.
That's it, exactly.
Okay, so if that was the brain in a jar, what does that make agentic AI?
Agentic AI is the brain with hands. It's proactive, it's goal-driven, and it's designed to persist over time. The 3 pillars are autonomy, statefulness, and agency.
So it doesn't wait for a prompt for every little step?
Not at all. You give it an objective, and it actively works toward that goal. It checks its own progress, it handles errors, it tracks its own internal status.
Okay, that concept of statefulness feels like the real game changer. For listeners who aren't super technical, can you break down how that lets an agent do what a chatbot can't?
Sure. Statefulness just means the agent maintains a persistent internal memory, its state, across lots of steps, lots of tool calls, even over hours or days.
Okay.
So imagine you ask an agent to, say, research and draft a competitive analysis report. The agent starts. It uses a search tool, it captures the results, and it saves its status internally.
Something like data gathering complete, report outline pending.
Exactly. And if the system crashes or you close the dashboard, the agent knows exactly where it left off. It knows what information it already has. The human doesn't have to re-upload all the context.
That's huge.
This ability to remember its place, its goal, its constraints, that's what lets it execute these complex tasks all on its own.
It sounds like a completely different architecture under the hood.
It is. I mean, if you look at the comparison table from the sources, GenAI's core function is basically content creation.
Right.
But Agentic AI's core function is task execution and problem solving. The output isn't just passive information. It's an active, measurable outcome.
And that must redefine the human's role in all of this.
Completely. You move from being the human as pilot constantly driving the tool to being the human as supervisor. Your job becomes orchestration and governance.
And if the agent is now the one driving toward the goal, the sources were really clear that the highly celebrated skill of prompt engineering is, well, it's rapidly depreciating in value. Why is that?
Because the agent is intelligent enough to manage the nuances of the prompt internally. You're not trying to craft one single perfect question anymore.
So what are you doing instead?
You're doing agent engineering and system design. You're defining the robust boundaries, the state machine, the tool set that this autonomous thing operates within. You don't prompt the agent. You architect its whole environment and its internal rulebook.
So the focus shifts from, say, linguistic creativity to just pure logical rigor.
That's a perfect way to put it.
Okay, that makes total sense. Let's talk economics then. We've seen augmentation for a while now, but the sources discuss this concept of the zero FTE department. How is that different from just having a co-pilot, and why is that the real economic engine here?
The zero FTE department is the thing that actually solves the GenAI paradox. It's the mechanism that lets organizations finally decouple capacity creation from human headcount.
Unpack that a bit. Decouple capacity from headcount.
Okay, so in the past, if you needed to scale up, say, level 1 customer support for a big product launch, you had to hire more full-time equivalents, more FTEs. That's a linear cost.
Right. More work, more people.
With Agentic AI, operational functions, L1 support, QA testing, compliance checks, they can be scaled instantly just by spinning up new agent instances, not by hiring new staff. It's infinite marginal capacity at a near zero marginal human cost.
The QA example in the material was perfect for this. It really shows how an entire workflow gets replaced, not just assisted.
Yeah, it's a great example. If you use GenAI, a human QA specialist might use the tool to write a test script, maybe 50% faster.
Which is good. That's augmentation.
It's good augmentation.
Right.
But the human is still in the loop. They're still executing the script. With Agentic AI, you give the system the overall goal, validate the new feature set.
And it just goes.
It just goes. The agent autonomously identifies all the necessary test cases from the requirements documents. It generates the scripts, it executes them, it logs the bugs directly into Jira or ServiceNow.
Oh.
And in some environments, it even tries to generate and apply its own code patches. The execution part of that job just vanishes.
So the human QA professional, their whole job transforms. They're not just getting a new tool. They become a QA strategist. They're designing the goals and the testing environments, not clicking the buttons.
Exactly. And this kind of organizational shift leads directly to the rise of what the sources call the frontier firm. Big companies like Microsoft are realizing this means the whole structure of the workforce is changing. It's becoming this hybrid ecosystem of humans and autonomous agents.
And that has to change how you measure managers.
Dramatically.
Yeah.
A manager's valuation isn't about the number of people they lead anymore. It's about the number of digital agents they can effectively orchestrate and govern.
And the scale we're talking about is just, it's mind-boggling. I mean, Jensen Huang's vision of managing 50,000 human employees and 100 million AI agents.
It shows you just how much machine capacity is going to fall under the umbrella of modern management.
So if you're in management today, your core skill isn't just managing human talent anymore.
No, it's rapidly shifting to managing digital capacity and ensuring it's governed robustly. The big takeaway here is that GenAI didn't move the needle because it was applied horizontally. One chatbot for everybody.
The frontier firm succeeds by applying agentic AI vertically.
Yes, automating specific, complex workflows from end to end, solving real business problems with measurable outcomes.
So, if the technology is making this fundamental leap from augmentation to full-on execution, then career paths have to follow.
They have to.
And our sources are really clear on this. They see a bifurcation, a split into two very distinct tracks. On one side, you have the technical builders who are designing these cognitive architectures. And on the other, you have the strategic orchestrators, the ones managing and governing the whole deployment. It feels like you really have to choose your lane because that generalist middle ground is just evaporated.
It's disappearing fast. And for the technical pros, this is where it gets really interesting. It's where system stability meets, probabilistic reasoning.
What does that mean in practice?
These new roles require a deep understanding of how to build reliable software when the core logic, the LLM itself, is inherently non-deterministic. It's not predictable in the way old code was.
Okay, so let's start with the first role on that builder track, the AI agent architect. To a lot of our listeners, that might sound exactly like the solution architect role they have now. Is it just a rebrand? Or are we just slapping the word agent on an existing job description?
That's a totally fair question, but the difference is actually profound. A traditional solution architect, they design a system of predetermined logic, right? If a user clicks X, the system does Y.
It's a clear flowchart.
A very clear flowchart. An AI agent architect, on the other hand, designs the system that decides for itself how to perform a task. They aren't defining the solution. They're designing the decision-making process.
The meta level above it.
Exactly. Their key responsibility is cognitive architecture design. They're the ones selecting the right reasoning pattern for the job like React, which is reasoning in action, or reflection, which involves self-critique.
And crucially, they have to design the state management strategy.
Yes, because agents are stateful, the architect has to design what's called a finite state machine, or FSM.
Okay, that's a classic computer science term, FSM. For the strategic listener, how should they visualize a state machine? What is it actually doing?
Think of it like a very strict flowchart for the agent's mind. The architect defines every possible major status, every state, and all the allowed transitions between them.
Give your example.
The states might be something like discovery, drafting, review, and finalized. The FSM ensures the agent can't just jump from discovery straight to finalized. It has to go through drafting and review.
So it prevents it from taking shortcuts.
And it prevents the single most devastating failure mode for an autonomous agent, the infinite loop. If the agent fails at discovery, the FSM dictates it has to transition to a different state, like query reformulation, instead of just trying the same failed search over and over again forever.
And I guess the architect also has to make sure that the tools the agent talks to, the corporate APIs, are robust enough to handle these, non-deterministic inputs.
Absolutely. The APIs have to be agent-friendly. They need to handle fuzzy language, but return predictable, structured data, so the agent can reliably understand the output and keep going on its reasoning path.
Okay, moving beyond the architect, there's this other highly specialized role, the agentic or GAG engineer. Now, we know standard retrieval augmented generation has been the backbone of enterprise GenAI for a while. It lets the LLM access internal company documents. But the sources are insistent on this point. They say standard RAG is proving insufficient for complex reasoning. Why?
Because standard RAG is usually just too blunt. It relies on vector search, which basically just finds documents that are semantically similar to your query.
So it's a fancy keyword search.
It's a very fancy keyword search. If you ask it, what are the common risks in all our Q3 supplier contracts? Standard RAG will find documents that mention suppliers in Q3, but it can't reason across all those different documents to give you a synthesized global answer. It can't do multi-hop research.
So the agentic or GAG engineer builds a system where the retrieval process itself is smart?
Exactly. Their main job is dynamic retrieval planning. The agent doesn't just search once. It performs a whole multi-step research strategy on its own.
So it would search, read the results,
realize it's missing data on a key subsidiary, generate a new, more refined query for that subsidiary, search again, and then synthesize the final report.
That's active research, not passive retrieval.
It is. They also implement something called graph RAG. This uses knowledge graphs, which are databases that explicitly define the relationships between things. Person A works for Company B supplies product C.
So it understands context, not just keywords.
It understands relationships beyond just semantic similarity, which is crucial for those big global synthesis questions.
And to tackle the big problem, the hallucination problem, they implement self-correction loops during retrieval.
Precisely. The agent critiques its own retrieved data, Before it synthesizes the final answer, it might prompt itself. Does this document I just found contradict our foundational policy manual? If it does, I need to flag it.
So it's a layer of verification built right into the process.
Right. And that internal critique mechanism dramatically reduces the risk of hallucination.
Okay, let's pivot now to the non-technical side, which I think is where a lot of our listeners are. This requires massive strategic thinking. We have the AI orchestrator, the new manager of digital capacity. They're bridging that critical gap between a fuzzy high-level business goal and the atomic, unambiguous instructions an agent actually needs.
This is, I think, the most critical shift for the entire management class. The single most important skill for this role bar N is task decomposition.
Task decomposition.
You have to be able to take a huge, high-level goal like automate the monthly financial close process and ruthlessly break it down into tiny, atomic, executable steps that can be assigned to different specialized agents or tools.
It's like being the general contractor for a digital workforce.
That's a great way to put it. The orchestrator defines the whole flow. Which agent verifies the invoices, which agent reconciles the ledger, which agent drafts the final report. And this manager is constantly engaged in exception management.
Right. Operating as the human in the loop or HITL manager.
Exactly. When an agent gets stuck, let's say a vendor invoice is missing a tax ID, it escalates that low-confidence item to the orchestrator. The orchestrator resolves the ambiguity, and crucially, they use that interaction to refine the system's logic.
So they're teaching the agent how to handle that exception the next time it comes up.
They're constantly teaching the system.
So as these agents start taking autonomous action, the organizational risk just skyrockets. You mentioned the Air Canada case earlier, where the chatbot made up a policy and the airline was held liable. This brings us to the AI governance and ethics officer role. Why are they so necessary now in a way they weren't for standard GenAI?
Because the agency is real now. GenAI talks. Agentic AI acts.
Right.
It can move money, it can sign contracts, it can send emails. The liability is massive. So this officer is responsible for defining the hard constraints on that action, implementing what the sources call constitutional AI.
What does constitutional AI actually look like in practice for a corporate agent?
It's the policy layer that you define in the agent system prompt or its configuration file. For example, agent may never authorize a refund over $500 without a human sign-off. Or agent must delete all personally identifiable information from its context window immediately after the task is complete. You're basically codifying legal and regulatory compliance directly into the agent's core behavior.
And their job also involves deep audit and compliance.
They don't just check the final outcome, was the task completed? They have to monitor the agent's entire reasoning path, the trace log, to ensure it followed all the policy rules, even if the outcome was correct.
So they can prove it was compliant.
And they have to design the kill switches, physical or digital kill switches, to manage the potential blast radius. If you deploy an agent to manage your social media ad budget, you need a way to immediately halt a runaway process that might try to spend $10 million in 5 minutes.
It sounds like this orchestrator role needs to be both a strategic manager and also deeply knowledgeable about the tech's architecture.
Absolutely. And this brings us to this new archetype that McKinsey identified, the M-shaped supervisor.
M-shaped.
Yeah, so the old T-shaped professional had broad knowledge and one deep specialization. The M-shaped supervisor has two deep spikes. One spike is in their business domain procurement law, supply chain logistics, whatever it is.
And the second spike?
The second spike is in the technical nuances of the agent architecture, how it reasons, what its common failure modes are. They're the strategic generalists who know just enough about the tech to intervene effectively when a complex agent failure happens.
That dual expertise.
That is rapidly becoming the most valuable commodity in the professional marketplace.
Okay, so for those who are dedicated to that builder track, the technical landscape is moving so fast. We're really out of the era of just making simple API calls. Mastering the frameworks for this complex stateful orchestration, that's the new hard currency for agentic engineers and architects.
We've definitely seen a rapid consolidation around three major frameworks, and each one serves a slightly different architectural philosophy. The first one is LangGraph. It's rapidly becoming the enterprise standard, and it builds on top of LangChain. Its dominance really comes from its rigorous focus on robustness and control. It treats the agent as a finite state machine, which we talked about earlier.
Right. So for the non-developers listening, why does that FSM approach make LangGraph so essential for a reliable business agent?
It really all comes down to control. Traditional workflow systems, they use something called directed acyclic graphs, or DAGs. That means the flow is strictly linear, A leads to B leads to C, and you can't loop back.
It's a one-way street?
It's a one-way street. LangGraph, however, supports cycles. And this is absolutely essential for complex reasoning that mimics how humans think, which is not linear. Draft to vote for view, edit, Beth, finalize.
That's a loop.
That's a loop, and it's impossible in a linear DAGs. By explicitly defining the FSM, LangGraph ensures the agent can robustly navigate those cycles without getting trapped, which is crucial for systems handling real-world tasks that require feedback.
The killer feature the sources mention is time travel and persistence. That sounds futuristic. What does it actually mean in a development context?
It's indispensable for debugging these non-deterministic systems, because LangGraph checkpoints the agent's explicit state at every single step. If an agent is doing a big financial reconciliation and fails on step 17 because it hallucinated a variable way back on step 4.
You're in trouble.
Normally, yes. But here, the developer can pause the execution. They can literally rewind the state of the system back to step 3, fix the bad variable, and then resume the execution from that point.
Without starting the whole expensive process over from scratch.
Exactly. It saves countless engineering and debugging hours for these critical long-running processes.
And it handles the human-in-the-loop part with more sophistication, too.
Yes. LangGraph allows for 2 types of interrupts. You have static interrupts, which are just hard-coded breakpoints for high-risk actions. The agent must stop before sending a payment. But critically, they also support dynamic interrupts. This is where the agent itself decides at runtime to stop execution and escalate to a human, because its own internal confidence score drops below a certain threshold.
That's smart. Okay, moving on, we have Crew AI. This one takes a less rigorous, more philosophical approach, right? Focusing on collaboration.
Crew AI is fantastic for multi-agent collaboration because it uses this really friendly role-playing metaphor. Instead of defining a complex FSM graph, you just define roles. You have a manager agent who delegates, a researcher agent who uses the tools, and a writer agent who synthesizes the information.
So the framework handles the delegation and feedback.
Right, based on those roles you defined. It's significantly faster to deploy for sequential pipeline tasks, where the output of one agent just becomes the input for the next. It mimics a human organizational structure really well.
And finally, Microsoft's AutoGen, which treats computation itself as a conversation.
That's its core philosophical distinction. AutoGen uses message passing. The agents chat with each other, they pass data and proposals back and forth until they collectively agree on a solution.
And its most unique feature is the user proxy agent.
Yes, and this is why it's the premier choice for any coding tasks. The user proxy agent safely executes code locally, usually inside a secure sandbox environment like Docker.
So what does that enable?
It completes this incredibly powerful self-correction loop. Agent A writes a complex Python script. It sends the code to the user proxy. The proxy runs the code, captures the output, and if there's an error,
it sends the error message back.
It sends the error message back to Agent A. Agent A reads the error, debugs its own code, and proposes a fix. This lets AutoGen agents write, execute, debug, and fix their own software autonomously. It's revolutionary for data analysis and development workflows.
So frameworks are kind of the operating system, but the core design patterns are the grammar. The standardized algorithms of thought. We need to go beyond the basics of React to really understand how these agents are being taught to reason deeply.
One of the foundational patterns for any complex reasoning is called plan and solve. This is absolutely vital for multi-step projects. The agent separates its cognitive load into 2 distinct phases.
Okay.
Phase 1 is high-level strategic planning. The agent generates a detailed, validated, step-by-step roadmap. Phase 2 is sequential execution, where it just strictly follows that plan it already made.
And what's the benefit of separating those 2 phases?
It prevents the agent from getting cognitively lost. If an agent tries to plan and execute at the same time, it can often drift or forget the overall objective. By setting a rigorous plan first, the execution phase becomes super focused and it prevents all those irrelevant tangents.
Which is crucial for systems that are going to be running for hours.
Definitely.
Okay, now let's dive deeper into the reflection or self-correction pattern. This is where that concept of the architecture beats model thesis really comes to life. Can you explain that process and why that thesis is so important for the builders out there?
Sure. Reflection involves setting up a separate agent, often it's called a critic, to review the output against a set of criteria. For example, a writer agent produces a draft.
Okay.
The critic agent receives that draft, along with a list of rules like the tone must be formal and it has to address points A, B, and C. The critic doesn't just grade it, it generates structured, actionable feedback.
Something like, point C is missing and the tone is too casual.
Exactly. And it loops that feedback back to the original writer agent for revision.
And this is where architecture beats model comes in.
Yes. The thesis is that the quality of this reasoning framework is actually more important than the raw size or intelligence of the underlying LLM. Researchers found that a lower-tier model, say the GPT 3.5, wrapped in a rigorous reflection loop where it can iterate and self-critique, often achieves higher quality, more robust outcomes than the latest, most powerful model, like a GPT-4, that's only allowed a single, non-reflective attempt.
Wow. So for builders, system design is the highest leverage skill, not just picking the biggest model.
That is the fundamental insight.
What about the most complex pattern, LATS, which is language agent tree search? You said this is reserved for extremely complex tasks. Why is that?
LATS is computationally very, very expensive because it involves massive parallelism. It borrows concepts from chess-playing algorithms, like Monte Carlo tree search.
Okay.
When it's faced with a complex decision, the agent doesn't just pick one path forward. It explores multiple possible future paths all at the same time. It scores each path based on its anticipated utility and potential risk. It's effectively thinking several steps ahead along several different timelines.
So what's that used for?
It's reserved for things like strategic financial modeling, deep scientific synthesis, or complex planning games, tasks where the number of possible correct steps is just enormous. It provides optimal reasoning, but at a huge cost in time and compute power.
Which is why plan and solve is preferred for most day-to-day business processes.
Exactly.
Okay, so we have to reiterate this. Because agents are probabilistic, you can't debug them like old software. A failure isn't a crash, it's an internal misstep, a logical error, a bad tool call.
Or a context window overflow. You have to know why the agent chose to do what it did.
Which necessitates this whole new field of agent observability. What kind of tooling are builders now required to master?
The gold standard, especially if you're in the LangChain or LangGraph ecosystem, is LangSmith. It gives you traces, which are visualizations of the agent's entire lifecycle.
Trace.
The trace lets you reconstruct the logic. Input LLM's internal thought process, tool calls will output next thought. It captures the entire internal dialogue and decision path, which is just impossible with standard logging.
So it's like a black box flight recorder for the agent's mind.
That's a perfect analogy. And this tracing is vital for curation. It lets developers find and isolate failures and create specialized test data sets, which accelerates the whole evaluation and tuning cycle.
Are there alternatives?
A key framework-agnostic alternative is Arise Phoenix. It specializes more in production monitoring, particularly real-time detection of logical drift, spikes in hallucination, and unexpected bias once an agent is live.
So the new critical skill isn't just coding, it's trace analysis. What does that actually look like in practice for an agent mechanic?
It looks like forensic detective work. You're looking at a failure trace,
Okay.
and you realize the agent failed not because its reasoning was wrong, but because the developer improperly configured the retrieval tool, and it returned 20 irrelevant documents.
Ah.
The sheer volume of that irrelevant data overflowed the LLM's context window, causing it to forget its original instructions halfway through the task. The failure isn't in the logic, it's in the context management. And you can only diagnose that by reading the trace of the tool output.
It's a totally new diagnostic skill set, bridging application engineering and probabilistic modeling.
Exactly. Now let's pivot back to the strategic orchestrator, the non-technical professional. Their success really hinges on developing a cognitive framework that's all about managing logic, systems, and risk, rather than just managing people and schedules.
Right. And we identified overscoping as the #1 failure mode. A manager asks for an AI employee that handles customer support, it's an entire domain. It's not an executable task. So how does an expert orchestrator approach a big problem like that?
The orchestrator has to use decomposition as a rigorous, formalized methodology. It's not just breaking a task down, it's breaking it down until the steps that are left are atomic. Meaning they're the smallest possible unit of work that can be executed by a single agent or a single tool without any ambiguity.
Let's use the dinner dilemma anecdote to really show the difference between a novice prompt and an expert's graph.
Okay, so a novice provides the fuzzy goal. Book dinner for 10 people. An agent might search, find one restaurant, and then fail because it's missing all the context.
Right.
The expert orchestrator, instead, designs a rigorous execution graph. Step 1, intent check. Confirm the purpose of the booking and the required date range. Step 2. Constraint gathering. Query the internal database for all 10 employees' dietary restrictions and their calendar availability. Step 3. Discovery. Execute parallel searches against specialized restaurant APIs based on all those constraints.
Step 4 is the action.
Selection and action. Present the top 3 options to the human for a final choice, then execute the reservation and payment. And then step 5, notification.
So by breaking it down, the orchestrator doesn't build one giant, complicated agent. They build a system of smaller, specialized agents, a constraint agent, a discovery agent, an action agent.
Each with a very narrow focus and really clearly defined input and output requirements.
So the Cree application here is profound. The ability to write a rigorous standard operating procedure, an SOP, that's the precursor to writing a system prompt for an agent.
Exactly. If you as a professional cannot meticulously document your own day-to-day workflow in extreme, unambiguous detail, you cannot manage the agent that will perform it. The first step for any orchestrator is to audit their own job and rigorously document their processes, turning them into machine-readable instructions. That skill set is now the foundation of the managerial layer. Trust is really the final bottleneck to full automation. Organizations are just not going to grant agents full autonomy in high-stakes environments without robust safety nets. And the orchestrator's job is defining and managing those nets.
We have to reflect on those cautionary tales, like the Taco Bell incident, where the AI drive-thru was trolled into trying to process an order for 18,000 water cups. The core problem there was a total lack of common sense, which led to a systems failure.
That's the classic failure mode. An agent rigidly adheres to its programming but lacks common sense, and it results in a catastrophic action. The orchestrator has to define the HITL spectrum and the required confidence thresholds to prevent this exact thing.
Okay, so you've delineated 3 levels of control that the orchestrator defines.
Right. First, you have human in the loop. This requires a human to pause and give explicit approval every single time before a critical action is taken.
High safety, low speed.
Very high safety, very low speed. You use this for things like fund transfers or signing new contracts.
Okay, level 2.
Second is human on the loop. The agent operates autonomously, but a human is actively monitoring a real-time dashboard and has the ability to hit the stop button or override the action. This is where the Taco Bell system failed. It didn't have a human monitoring that ridiculous order volume.
And the third level.
Human out of the loop.
Yeah.
Full, unmonitored autonomy. And this is reserved only for high-confidence, very low-stakes tasks like summarizing internal reports or recommending content.
So the strategic insight here seems to be that the smart career move is to position yourself as the safety engineer. You become the person who defines the criteria for the confidence thresholds and the escalation protocols, ensuring the financial and legal safety of the organization's autonomous assets.
That is the new high-value role.
So managing all this liability, it requires adopting a cybersecurity level of rigor for these Silicon employees. What are the core competencies for an orchestrator here?
They have to first understand that agents are susceptible to cybersecurity attacks, specifically prompt injection. That's where users try to jailbreak the agent by providing malicious inputs that override its constitutional rules. The defense requires applying cybersecurity principles, and most important one is least privilege access.
Can you give us a concrete example of applying least privilege access to an agent? How would an orchestrator actually implement that?
You segment the agent's permissions based strictly on its function. For instance, if you deploy a scheduling agent, its function is limited to managing calendars. So it should have calendar read-write access.
Makes sense.
It might need read access to the contact list to find email addresses, but crucially, it should be explicitly denied access to the sensitive email archive or the HR employee salary database.
So if that agent gets compromised...
The blast radius is limited to scheduling chaos, not a massive data leak. The orchestrator is the one who defines those permission boundaries with rigor.
And beyond that...
Furthermore, they must ensure every single agent action generates audit logs. These logs are your legal and compliance documentation. The governance officer has to be able to reconstruct, post-mortem, precisely why a decision was made to demonstrate adherence to all the internal and regulatory policies. The Air Canada case taught us, if the machine makes a mistake, the company pays. Auditability is now synonymous with liability management. Okay, so we've covered the technical and the strategic landscape. To wrap all this up, we need to convert these findings into a tangible, prioritized checklist. And the core success strategy, reinforced across all the sources, is the move toward vertical workflows.
Let's revisit that mistake. Building horizontal agents. These are the generic company co-pilots that try to assist everyone with diffuse, low-stakes tasks. And they often stall because the ROI is just so hard to measure.
The success strategy is relentlessly focused on vertical agents. These are narrow, deep workflows that automate one specific high-friction process from end to end. You should think less AI for finance and more the agent that processes all cross-border tax documentation.
Specificity is key.
It's everything. The H&M case study is the perfect illustration of this. They didn't build a generic customer service chatbot. They deployed a very specific virtual shopping assistant agent vertically integrated right into their mobile shopping experience.
And that narrow, deep focus.
It led to a 70% reduction in human query volume within that specific flow and a massive 25% increase in conversion rates because the agent was highly effective at its one dedicated task. The ROI is immediate and it's measurable.
And for data-rich organizations, legal, finance, R&D, the big implementation pivot is upgrading their existing data systems from standard RAG to Agentic RAG.
Yes, this is what turns passive data retrieval into active analytical research. Instead of the agent just retrieving a list of documents, the Agentic RG system acts as a reasoning researcher.
So it'll retrieve the initial reports.
Analyze the content for key figures, generate new follow-up queries based on those figures, like, now calculate the average revenue from these 3 PDF reports I just found, and then synthesize a net new analysis based on all the retrieved data. This is how data-heavy organizations unlock real productivity gains.
Okay, we've broken the sources roadmap down into 3 time-bound phases. This is your actionable checklist.
Phase 1, immediate pivot, months 1 to 3.
Yeah.
First, choose your lane, builder or orchestrator. You have to stop thinking in linear prompts. You must adopt the graph mental model loops, states, conditional decisions.
So what does that mean in practice?
Builders must get hands-on with LangGraph to master state machines. Orchestrators need to master the logic of agent interaction, maybe starting with a low-code tool like Crew AI to really understand delegation.
Okay. Phase 2, deep skilling, months 3 to 6.
Master decomposition. Practice writing atomic, rigorous SOPs for every single part of your current job. If you can't decompose it, you can't automate it. Then get hands-on with observability. You need to become the agent mechanic.
By using a tool like Langsmith or Arise Phoenix to learn how to read, trace, and diagnose system failures.
Exactly. And crucially, you need to build and deploy one vertical agent that solves a single high-friction problem in your current organization and proves the ROI.
And finally, Phase 3, strategic positioning, month 6-12.
This is all about managing liability. Volunteer to draft your organization's AI safety guidelines. Be the person who defines the confidence thresholds and the HITL protocols. This positions you as the risk expert.
And the final step.
You must audit your own current job tasks to identify what can be offloaded. Be proactive about this. Be the first person to automate yourself so that you manage the automation rather than being replaced by it.
The overarching conclusion of this deep dive is just so clear. Career value is fundamentally migrating away from the routine execution of knowledge work and decisively toward the architecture, the orchestration, and the governance of the intelligent systems that perform it. We're not just entering the age of the AI worker, we are entering the era of the manager of infinite capacity.
And this capacity is going to soon span both corporate and personal domains. And those boundaries are blurring very, very rapidly. So as we close, consider this. If on-device agents, like the highly private local AI that's going to be running on new devices, are handling our personal tasks, how will enterprise orchestrators govern the necessary interface points between those highly private local agents and the corporate cloud-based agents?
Wow.
You're going to have highly secure local identity, meaning corporate governance requirements. And this raises a really important question about identity, compliance, and the very boundaries of the professional environment that we are all going to need to solve very, very soon.
That is a fascinating thought to consider. We encourage you to start your own journey into agent orchestration by taking that first step today. Analyze one routine task in your daily workflow and ruthlessly decompose it into atomic steps. You've just drafted your first agent architecture.